How are you? So, in this video, I will be discussing the topic of 10 projects where machine learning was involved in one or other way. Machine learning has become one of the mainstays of information technology over the past few decades. It is a new data analysis domain which is becoming popular to automate advanced analytical model building by utilizing new algorithms that repeatedly updates from data. It permits computers to search out hidden patterns and insights from the data. Due to the growing volumes and varieties of the available data, computational processing is cheaper and more powerful, and thus the increasing demand for knowledge of machine learning. And here also machine learning domain. Machine learning is getting used today in many different domains, and some of them are fraud detection, web search, text mining, recommendation systems, network instructions, and etc. Importance of machine learning is the use of machine learning has gone through to a different level where it has been used in different areas. Some of them are enhance their shopping experience, enhancing the security at the border crossing, enhancing the decision making system. So at the end, the next topic is machine learning projects. So let's start. So the first topic is sentiment analysis. Project number 1. Sentiment analysis or opinion mining or meaning is a simple task of understanding the emotions of the writer of a particular text. What was the intent of the writer when writing a certain thing? We use various natural language processing NLP and text analysis tools to figure out what could be subjective information. We need to identify, extract, and quantify such details from the text for easier classification and working with the data. But why do we need sentiment analysis? Suppose sentiment analysis serves as a fundamental aspect of dealing with customers on online portals and websites for the companies. They do this all the time to classify a comment as a query, complaint, suggestion, opinion, or just love for a product. This way they can easily sort through the comments or questions and prioritize what they need to handle fast and even order them in a way that looks better. Companies sometimes even try to delete content that has a negative sentiment attached to it. It is an easy way to understand and analyze public reception and perception of different ideas and concepts or a newly launched product, maybe an event or a government policy. Our second project is movie recommendation system. So before build a project, are you know what is recommendation system? Recommendation system are computer programs that suggest recommendation to user depending on a variety of criteria. These systems estimate the most likely product that consumers will buy and that they will be interested in. Netflix, Amazon and other companies use recommender system to help their users find the right product or movie for them. There are 3 types of recommendation system: demographic filtering, content based filtering, and collaboration based filtering. Ever wondered how Netflix or Hotstar recommends new movies based on the watch history? How Amazon or Flipkart suggests new products based on your order or search history? These suggestions or recommendations are done by a system called a recommendation system. This engine makes suggestions by learning and understanding the patterns in your watch history. Our third number project is email spam detection. In recent times, unwanted commercial emails called spam has become huge problem on the internet. The person sending the spam messages is referred to as the spammer. Such a person gathers email addresses from different websites, chat rooms and viruses. Spam prevents the user from making full and good use of time, storage, capacity and network bandwidth. The huge volume of spam mails flowing through the computer networks have destructive effects on the memory space of email servers, communication bandwidth, CPU power and user time. To efficiently handle the threat posed by email spams, leading email providers such as Gmail, Yahoo Mail and Outlook have employed the combination of different machine learning techniques such as neural networks in its spam filters. These machine learning techniques have the capacity to learn and identify spam mails and phishing messages by analyzing loads of such messages throughout a vast collection of computers. Since machine learning has the capacity to adapt to varying conditions, Gmail and Yahoo Mail spam filters do more than just checking junk emails using pre-existing rules. They generate new rules themselves based on what they have learned as they continue in their spam filtering operations. The machine learning model used by Google have now advanced to the point that it can detect and filter out spam and phishing emails with about 99.9% accuracy. The implication of this is that 1 out of 1,000 messages succeeds in evading their email spam filter. The statistics from Google reveal that between 50 to 70% of emails that Gmail receivers are unsolicited mail. Our next project topic is music generation. Music generation using deep learning techniques has a topic of interest for the past 2 decades. Music provides to be a different challenge compared to images among 3 main dimensions. Firstly, music is temporal with a hierarchical structures with dependencies across time. Secondly, music consists of multiple instruments that are interdependent and unfold across time. Thirdly, music is grouped into chords, arpeggios and melodious. Hence, each time step may have multiple outputs. However, audio data has several properties that make them familiar in some ways to what is conventionally studied in deep learning, computer vision and natural language processing model, that's called NLP. The sequential nature of music reminds us of NLP, which we can use recurrent neural networks for. There are also multiple channels of audio in terms of tones and instruments that are reminiscent of images that convolution neural networks can be used for. Additionally, deep generative models are exciting new areas of research with the potential to create realistic synthetic data. Some examples are variational autoencoders, generative adversarial networks, as well as language models in NLP. Our next project is Human Activity Recognition. Shortcut form is HAR using machine learning. Device sensors provide insights into what person are doing in real time, walking, running or driving, etc. Knowing users' activity allows for instance to interact with them through an app. In this regard, you can apply machine learning to detect activities by reading and processing sensors data. Human activity recognition aims to classify a person's actions from a series of measurements captured by sensors. Nowadays, collecting this type of data is not an arduous task. With the growth of Internet of Things, almost everyone has some gadget that monitors their movements. It can be a smartwatch, a pulsometer, or even a smartphone. Usually, this is performed by following a fixed length sliding window approach for the features extraction. Here, two parameters need to be fixed: the size of the window and the shift. There are some of data you could use: body acceleration, gravity acceleration, body angular speed, body angular acceleration, etc. Activity recognition is the basis for the development of many potential applications in health, wellness and sports. Monitor health, discover activity and patterns, detect activity, improve well-being, and such more types. Human activity recognition has a wide range of uses because its impact on web. It is becoming a fundamental tool in healthcare solutions such as preventing obesity or caring for elderly person. Our next project topic is face recognition and clustering. Face recognition and face clustering are different but highly related concepts. When performing face recognition, we are applying supervised learning, where we have both images of faces we want to recognize along with the names that correspond to each faces. But in face clustering, we need to perform unsupervised learning. We have only the faces themselves with no names or labels. From there, we need to identify and count the number of unique people in a dataset. The magic of face recognition is still supervising us in every moment. We see a sci-fi movie about artificial intelligence. That's why diving in this subject, working on and writing about it had the purpose of revealing the secret of measuring technology. Another concept is K-means clustering algorithm. K-means algorithm is an unsupervised machine learning algorithm that tries to cluster similar data into K cluster, where each cluster has a centroid that represents it. Each cluster contains the data that are similar as much as each of other as possible, and of course the data is not the same cluster are as different as possible. Our next project topic is chatbots. A chatbot, conversational artificial intelligence, is an automated program that simulates human conversation through text messages, voice chats, or both. It learns to do that based on a lot of inputs and natural language processing, or NLP. For the sake of semantics, chatbots and conversational assistants will be used interchangeably in this video. Why does your organization need a chatbot? In an Oracle survey, 80% of business answered that they use chatbots, and 48% are already using automation technology. The global chatbot market is expected to reach $1.23 billion by 2025, with a compounding annual growth rate of 24.3%, according to a Grand View research report. What are chatbots used for? For scaling operations, task automation, user engagement, social media integration, data generation, ability to speak multiple languages, connect with your younger customers. Industry where chatbots can help: also customer service, e-commerce, healthcare, travel and tourism, banking and finance, food services and grocery stores. Our next project topic is neural style transfer. Neural style transfer is an optimization technique used to take three images: a content image, a style reference image such as a artwork by a famous painter, and the input image you want to style, and blend them together such that the input image is transformed to look like the content image but paint in the style of the style image. The principle of neural style transfer is to define two distance functions, one that describes how different the content of two images are and one that describes the difference between two images in terms of their style, L style. Then given the three images as desired style images, it is a desired content image and the input image initialized with a content image. We try to transform the input image to minimize the content distance with the content image and its style distance with the style image. Our next project topic is dress or makeup transfer. This algorithm represents body pose and shape as a parametric dress that can be reconstructed from a single image and easily reinforced. Given a specific image of a person, they were able to synthesize a new image of a person in a different target body pose. This new technique is basically composed of four main steps. Using density pose developed in another paper, they were able to use the correspondences found between the input image and the SNPL in order to extract the partial texture represented in the UV texture map, and then using feature net, which is unite like convolution network. They convert the partial UV texture map to a full UV feature map, which gives a richer representation for each texture pixel. The third step to take a target pose as input as well as the UV feature map recently found in order to render an intermediate UV feature image. Finally, use RenderNet, a generator network based pix-to-pix HD, which can be used for turning. Our next and last final project is colorizing black and white images. The idea behind this is to develop a fully automated approach that will generate realistic colorization of black and white photos and by extensions videos. As explained in the original paper, the authors embraced the underlying uncertainty of the problem by posting it as a classification task using class rebalancing at training time to increase the diversity of colors in the result. The AI approach is implemented as a feed-forward pass in a convolutional neural network, at least or at test time, and it trained on over a million color images. Here, a photo shoot, usually we are used to coding a color photo using the RGB model. The RGB color model is an additive color model in which red, green and blue light are added together in various ways. So the total things you can develop using machine learning of Python, and also we can use NumPy, Pandas and many Python libraries. So at the end of the video, I told you that you can add this top 10 machine learning projects in your resume to get a better interview in highest multinational industry. So it is better opportunity for you to explore this type of machine learning projects. So goodbye and see you later.